All right, so 3.8, derivatives of inverse trig functions. Today we are going over 3.8, and then is this the last class of the week? Yeah. And then on Monday, we'll go over 3.9. Tuesday, plan is review, and December 2nd is the test. And I'll let you know on Monday if I'm deciding to have a review or not. Anyone pushes me 1 ounce, I'm not going to buckle, and I'm just going to make your test be the second. So just let me think about it. So 3.8, derivatives of inverse trig functions. So we learned that the graph of an inverse trig function can be attained by reflecting the graph of f across the line y equals x. So low review from Algebra 2. Here is, x, y, and if I have a graph x squared, you can find the inverse function by reflecting it across the line y equals x. So the line y equals x, I shouldn't have picked green. Let me change the color. So top of page 9 with 3.8. Yeah. Okay. I'm just trying to generalize what this will look like. Okay, so this reflects across, oh my god, that's not looking nice. It looks like this. This would be the inverse. This is top of page 9, 3.8, derivatives of inverse trig functions. If you need another copy of the notes, just let me know. All the solutions to the field notes are online as well. Okay, so this is how you do it graphically. You reflect it across the line y equals x. So if exactly, okay, so imagine this, and I'm reflecting across horizontally, so I want to reflect it across the horizontal. This is hard. So look this way. Because it's not a horizontal, I'm not reflecting across the x-axis or the y, I'm reflecting it across a 45-degree angle, the y equals x line. That's what the arrow is showing, is the y equals x line. So if it was above, right, I swing it below. If it's like it's almost like a little U.
Swinging like that side.
I'm trying to swing it across this line, the blue arrow. All right, so that's graphically. So if I want to do it algebraically, I have the graph y equals x squared. If I want the equation of the inverse, what you do is switch your variables and then get y by itself. Okay, what does this look like? Switch your variables and then get y by itself. So switch the variables mean put a y where there's an x, put an x where there's a y. Now get y by itself. So I see y is equal to plus or minus square root x. And that's literally what it looks like, right? This one right here, positive root x. The one below, negative root x. Hey, we got it. Okay, that's a little review, because now we're going to talk about inverse trig functions. So do you remember inverse trig functions? Where cosine is literally, cosine, sine are waves. But if I want the inverse, so throw it back to chapter 1, section 6 of this year. Inverse have restricted domain. That way they can actually be functions. Because what would happen if I took sine and reflected across y equals x? So if, let's see, so I'm taking sine, and if I want to reflect it across the line y equals x, reflecting it across, literally it's going to be...
What? That is
because you're taking it and reflecting it across this line. Okay, so imagine, so ready, take your head at a 45-degree angle. Okay, and then you're reflecting it across this axis. That's what I'm trying to have you see. So you turn your head, so that way you're looking at this like it's a flat line, and it looks like I'm just reflecting it across this line. You see it now? Yeah. Take your head, tilt it, that way your frame of reference is now just a flat horizontal line, and you can see how I just did a vertical reflection. Okay, issue, right? This is the inverse function. It's no longer a function because it doesn't pass a vertical line test. So this is why we restrict it. So when I have sine, it just looks like that. So this is more or less, dang, I was so close to getting it perfect. Go through here. Okay. So this is what the inverse of sine looks like. Cosine similar, tangent similar. So you scroll back, we kind of remember this a little. Yeah, okay, maybe. Look at your 1.6 notes. Maybe just a tad, just to see what like the graphs would look like. Anyway, the point is, as the following figure suggests, right, so you see these two graphs, the reflection of a continuous curve with no cusp or corners will be another continuous curve with no cusp or corners. So sine and cosine are continuous, nice, smooth curves. If I take the inverse is also going to be smooth. If there is no cusp to begin with, when I reflect it, there'll be no cusp to end with. Right? If I have a nice smooth curve and I take the inverse, it's still going to be a nice smooth curve. Okay, if there's a tangent line to the graph at this point, that means that tangent line will reflect across y equals x to become a tangent line to the graph at the inverse at the point f of a equals a. Okay, so here's my x and here's my y. Remember, your inverse is literally just flip the x and y's. That's why, oh, my x turned into a y and my y turned into an x. Nice, inverse. I remember vividly going over this last year. Okay, so how does my slope change? You can see it's going to be the reciprocal of the slope of the original tangent line. Yeah, okay, cool. So, like, that's the more or less hardest part. So if this slope is going to be, right, let's say this slope is 2/3, what would the slope of this line be? 3/2. It's just literally the reciprocal. Perfect. What else do I need to say about this? No, I don't think I need to say anything else. All right, so example 1. Let f of x equal x to the 5th plus 2x minus 1. The point 1, 2 is on the graph of f. Find the derivative of the function at 2 without finding a formula for the inverse. Okay, so just to be clear, what this here means, it's the slope of the inverse function at x equals 2. Is that what I said? I think so. So make sure I'm saying it right. I forgot what I did last night, but I was doing the clock at the game, and I did something stupid and I got yelled at. You know you messed up when both coaches are yelling at you. Yeah.
It's okay. I got mixed up by a teacher.
I forgot. I was really tired and I was like, oops, I think I added the vowel to the wrong team, and then immediately, like, oh, because they're in double bonus.
Is it in the game?
Yeah, it was in the 4th quarter.
I think the last 25 seconds is the most stressful part of the game, coming through the clock.
Were you watching?
No.
No, anytime there's like 10 seconds or less, I make Angel do it. Yeah, it's Alvin's daughter. I make her do it. I'm not gonna touch that. Okay, so no, since f of 1 equals 2, the inverse, your x and y switch. So you know for the inverse function, when y equals 1, x is 2. Right, so if you look at the regular function versus its inverse, the x and y just switch. Okay, I think I've said that 50 times today. All right, first, let's find f prime, right? The first derivative of the original function. Okay, so hopefully this will be a nice little warm-up. Let's go through. Who wants a... Yes, tall.
Okay, so
F prime of x?
F prime of x equals x to the... wait. Oh, okay, 5x plus 2.
5x to the 4th.
5x plus 1 plus 2.
Bomb.
Wait,
okay.
I'm sorry, wait.
We're warming you up to be prepared for trig inverse derivatives.
What was the whole thing with...
So, ready? So if I find the slope at this point, I can just do the reciprocal and it would be the slope of the inverse. So, we don't want to find the formula for the inverse function. But we want to find the slope, the derivative at a point at the inverse. So I can do is find the derivative of the original function, find the slope at that one point, and then take the reciprocal. Okay, so I have the derivative of the original function. All right, now let's evaluate this at 1. So what I'm doing, f prime of 1 means the derivative at 1. It's telling me the slope at 1. That's the trick play, all right? Whenever you're finding the first derivative at a point, that's telling you the slope at that point. Okay.
Like any point?
Well, yeah, I could find any point, but when I say f prime of 1, that'll be the slope at 1. It's just something people keep missing, and I don't know why. Because point slope form should be like the easiest thing. Okay, so we have the slope. What? I know, and I don't even hide it. You guys, I don't hide it. It's right there. I've left it up the whole time. I just don't point it out. I'll be like, hey, look, don't cover it. Yeah. No worries. Okay, so step 4, after we found the derivative at x equals 1, we would need to find the derivative at the inverse at 2, because remember, that's the x value when y equals 1. So this is just going to be the reciprocal. What's the reciprocal of 7? 1/7. Hey, look at you go. 1 page down, 2 to go. Woo, yeah. Well, for this page, yeah.
No, I'm saying, what is all that taking on?
Hi, can you take it forward?
What?
Hi, can you just take it as a Thanksgiving?
You want to take the test for
No.
Thanksgiving? You want to?
No.
Then what was your face? What were you saying?
I'm making a joke because we're going so quickly.
No. Going quickly, what's the reciprocal of 7? 1/7. Okay.
Wait, but what is the DF, formula for DF equals
Yeah, okay. So let me point out right here. Let me break this down. So df's a -1 dx at f of a. So this is going to be my y value. And then this a right here is the x value of the original function. So what we're trying to do is, okay, if I know the slope at my original point, right, the reciprocal slope, the slope at the, like, corresponding inverse point, right, so you switch your x and y, so the slope at that point would be the reciprocal of the slope at your original point. So that's why I have an x value of 2, because this is the original y. And this is why I'm using, so I know it's the reciprocal of my original slope. Okay, that's just talking myself in circles. So, okay, questions? No. So more or less, if you're looking at a certain point, you can find the derivative of your original function at your x point, and if you're wanting the inverses derivative at the point where the y of your original point is your new x of your inverse, you can find it. All right, derivatives of inverse functions. If f is differentiable at every point on an interval I, and df dx is never 0, so the derivative of the function with respect to x is never 0 on the interval, meaning we don't have a horizontal tangent. Because imagine if I took the reciprocal, yikes, then f has an inverse, and f inverse is differentiable at every point. Okay, so you will have to know these two. You will have to these are the two most useful, and they pop up everywhere in chapter 8 and 10. I think it's 8, sure 10. Yeah, I'm gonna break it down. Traffic?
Oh.
Yeah, I got you. Screencasting. Okay, so let's break it down. So notice this is sine inverse of u. So this is an inverse function. So the derivative of sine inverse is 1 over square root 1 minus u squared. That's just what it is.
What's u?
So u is, if I don't just have sine inverse of x, what if I had sine inverse of x squared plus 4, like a function inside?
Mm-hmm.
So we're using chain rule.
Oh my god. So we always have to use chain rule.
Because most times, you're not just going to have sine inverse of x. Here, it's 8x squared. So you're using chain rule to take the derivative of sine inverse and then multiply by the derivative of what's inside. Similarly here, I'm taking the derivative of tan inverse and then multiplying by the derivative of the function inside. Well, the function inside is x over 2, so you can find the derivative of that. Okay. So tangent is just 1 plus u squared. So keep in mind, u is the function that's inside, and you're actually going to have to plug it in right here. Because it's not, unlike sine of x, where we take the derivative and it's cosine x, It's not just, I'm not just keeping the exact same thing. It's literally this formula. You're taking 1 over square root u minus u squared and then multiplying by the derivative of what's inside. So it's an algebraic expression, right? The derivative of a trig inverse function is an algebraic expression in terms of x. It is different than when we take sine derivative for cosine. Right? Normally we take sine's derivative, and it's going to be cosine. I leave the thing inside. Here, I feel like if I do the first example, it would better explain it. Because then you'll see what I'm trying to say. Okay, so here, if I want to write this in terms of u, I have y equals sine inverse of u, except what is u equal to here? 8x squared, right? It's what's inside. So I know the derivative of sine inverse, so I'm taking dy dx. So I'm taking d dx of both sides, so I'm just taking the first derivative, right? dy dx, same thing as y prime, just make sure we understand that. So I'm saying that's going to be, okay, derivative of sine inverse is 1 over square root of 1 minus u squared. So 1 minus, and remember my u is 8x squared. I need to make sure that's all under my radical. And then I have to multiply by.
Wouldn't it just go away?
What goes away? No, because this is 1 minus u squared. If it was just u squared, then I could cross it out. But it's a binomial, 1 minus this thing. Multiply by the derivative of u. The derivative of u, yeah. So u prime is going to be 16x. So to write this, simplify it a little bit, I have 16x over square root of 1 minus 64x to the fourth. Because I square the 8 and I square x squared. This is the answer. This is it. So what I'm trying to say is, notice when we have sine, and when I take the derivative of sine of x, if I take the derivative of sine of x squared, let me make this a little aside. It would literally be cosine of 8x squared times 16x. Notice that I still have a trig function if I have my regular trig function in the okay. Notice I have a trig function in my derivative for a regular trig function, but here we have inverse. So inverse derivative is all algebraic. 1 over square root 1 minus u squared. So it has no trig function in the derivative. Elliot, put your phone away. It should be over in the red. Take this time, if you have not already, put your phones in the red holder. Just do it. Just go. Don't distractions. So notice, regular trig function has trig function and derivative. Inverse trig function, no trig function and derivative. I'll say it one more time. Regular trig function in the blue highlight has a trig function and the derivative. Inverse trig function in the green has no trig functions in the derivative. It's all algebraic. All algebraic. Okay.
Okay. Inverse, can I repeat that?
Sure.
Inverse trig function is all algebraic. There's no other trig functions in it. But if you have a regular trig function, there's going to be a trig function in it.
Yes.
Okay, I'm going to write that down. You know what?
Yeah. So if you just have a regular inverse trig function, you're just going to put it in terms of
Regular inverse trig.
so if you have a trig, if you have an inverse trig,
It's going to be
algebraic. Regular trig,
Inverse trig
yeah.
equals regular
Oh my gosh.
trig equals regular trig.
So we'll have a regular trig in the derivative. Okay, so notice there's two derivatives of inverse trig functions you must know. Yeah, you gotta know it. And these are the two most important ones. That's why these are the two you have to know. Hopefully, we will use them so much you will just have them at the tip of your tongue. That'd be great. Okay, so I'll be uploading the filled notes as well as the screencast. Okay. All right, so y equals tan inverse of x over 2. So what I'm going to do is I'm going to write this as y equals tan inverse of u. Here, u is equal to x over 2, and u prime is going to be 1/2. Cool. So let's go ahead and let's find the derivative. So I'm going to take derivative of both sides. dy dx is going to equal, so I have to use the 1 over 1 plus u squared, right? Derivative of tan inverse is going to be 1 over 1 plus u squared. So u squared is x over 2 times the derivative of u, because we're using chain rule. Right? We take derivative of the outside, tan inverse, times the derivative of the inside, x over 2. So this is going to be times by 1/2.
You don't include the 2, right?
What? What did you say? Okay. Cool. Okay, so let's do a little simplification. So this is the same thing as, I don't know, I made it up. Let's simplify. A simplification is a noun, yeah. 1 over 1 plus x squared over 4. So all I did was I moved this to the front, because you know what I'm going to do? The big old distribute, probably. We'll see. Okay. So I have a fraction, and the bottom of my fraction, I need to make a common denominator.
Is this pretty much the chain rule?
Well, exactly. We use the chain rule.
Using these things?
Yep, that's exactly what it is. Solid. Solid. Okay. All I'm doing now, I've done the derivative, I've done the hard work. Now it's the algebra. I have to make a common denominator.
The algebra is the hard part. Oh, you actually have to like. Tame Impala?
Yeah, I like it.
It's dope. Are you gonna see him when he comes to LA?
Dude, tickets are probably crazy.
The pre-sale tickets came out the 9th of November. Yeah.
I didn't know that. I'm thinking of
I'm really excited. I'm going. I'm so excited.
For the one day of
Mr. Bryan has like 6 tickets already.
No, I have 2. I have 2 tickets.
Mr. Bryan buys one
Take
boy,
me.
sells it to his
Take
students.
me. Well, whoever gets 100% on the finals, that's who gets
Only if my friend gets sick. Like,
Frank gets
Actually,
sick, I would like
no, I would take a different friend. I wouldn't take you. No offense. No offense. No offense. Okay. Guys, we gotta simplify this. Come on. We gotta simplify this. Let's finish the lesson. Let's simplify this. Let's go. Okay. So I'm gonna rewrite this as 1/2. So times, if I'm dividing by a fraction, it's the same as multiplying by the reciprocal. Because if I am dividing by this, same thing as multiplying by the reciprocal.
But it's a fraction in a fraction.
Yeah, I know. Imagine I'm dividing by 1/2. This thing right here is the same thing as saying, oh, I'm trying to draw an arrow. The same thing as saying 1 divided by 1/2. So this is the same thing as saying 1 divided by 4 plus x squared over 4. So that's why I can multiply by the reciprocal. Haha. Math. Yeah.
Should be 1 times 4. And then we have to multiply it.
Simplify this a little bit.
Yeah, you can cross cancel.
Whoop. Whoop. Done.
Wait, let me copy it.
No, okay. Huh? What is wrong? Okay, so I started beginning a screencast, so you gotta listen to me talking about the due dates and stuff, and telling Spencer if he budges 1 more ounce, trying to push me to move the test, I won't move it. This thing right here, let me explain it a little more. 1 over this whole fraction thing, it's literally 1 divided by 4 plus x squared over 4. So that's why right here, instead of dividing 1 by it, I could say 1 times the reciprocal.
It looks like watermelon colors.
Useful knowledge, thank you. Okay, and then here I can simplify 2 and 4. It's good. Okay, cool. I'm glad you like my colors. Do we have questions over this? I don't think that's calculus talk. Yeah, okay, so let's not do it right now. Okay, do you have questions over this one?
No, actually.
Are you just messing with the calculator now?
He's probably like putting all this in his calculator so the calculator.
It's a for function. Do you see what he's doing? It's not even a real. Okay.
Writing words.
Example 2. A particle moves along the x-axis, so its position at any time t is greater than 0 is x of t equals tan inverse of root t. What is the velocity of the particle when t equals 16? Oh, we have the position equation. We want velocity. So, aka, that's just going to be the derivative of x of t. The velocity is just going to be the derivative. Okay. What? Position. Derivative of position's velocity. I have my position equation. I want the velocity. I take the first derivative. Then I'm going to plug in 16 for t.
Okay.
Boom. Okay. So, because that would tell me the position. I don't want the position. I want the velocity.
you have to do that and then.
Yeah. So I know v of t is just going to be x prime of t. X prime of t. Okay. So I'm going to write this as, I'm going to say x of t is equal to tan inverse of root t. So this means u is equal to root t, right? So imagine I'm writing this as tan inverse of u, like our equation at the top of the page. I'm writing it the way why are you just coloring? You do you. Okay. U is equal to root t. I was looking at you. Whatever.
Oh, okay.
U prime. What is the derivative of square root t?
Plus or minus t. What?
1/2
Derivative?
t,
1/2 t to negative 1/2, aka 1 over 2 root t.
Whoa.
I might just leave it in terms of 1/2 t to the 1/2. The negative 1/2. We'll see. We'll see. Okay, so I have what u is. I have what u prime is. Now we're going to do chain rule. First, derivative of tan inverse is going to be 1 over 1 plus u squared. U squared. So 1 over root t squared. Oh my gosh, you know something's going to happen here. Multiplied by the derivative of u, aka the derivative of what's inside. We know what's inside. The derivative is 1 over 2 times root t.
Oh, and then the square root and the square
you're just taking u.
Exactly. So this is right, the derivative of tan inverse.
Yeah.
This is derivative of u, aka u prime. Now, oh my god, why did I write so big? Okay, whatever. All right, so v of t, aka the velocity equation, is going to be 1 over, 1 plus t times 2 root t. I'm just going to leave it this way.
You just have to know that the velocity equation is
The first derivative of
x prime
position.
times t.
Yeah. Yes.
Wait, 1 plus t.
1. Well, because what's the square root of t squared is just t.
Right.
All right. So square root and squared cancel out, and that's why I'm left with just 1 plus t, and then multiply by 2 root t. So
How do you know that the velocity of t is that? You just have to memorize that the velocity equation is that.
the velocity is the derivative of position. So I have the position equation was this, so I find the derivative, and it will give me velocity.
Oh my gosh.
So velocity is derivative of x of t, aka derivative of position.
Derivative of
Position.
position.
Yes. Now, we didn't just ask for, oh, what's the velocity equation? No, we want the velocity at 16 seconds. So we got to plug in 16 for t. So I want v of 16. It's going to be 1 over 1 plus 16 times 2 times root 16. It's all good. Do you have your notes? No? Okay.
I was in a rush. You
Yes, it
also
is.
send the picture.
It's fine. I'm gonna fill there's screencast and I'm gonna upload the filled anyway. I think there's like 4 people here actually at 8 with the traffic.
So now you're just plugging in 16.
Yep, because I want the velocity at 16 seconds. So this is 1 over 17, let's see. Oh, I need to. 1 over 17 times 2 times 4, so 17 times 8. 136. 1 over 136.
Damn, we crushed it.
That's really slow. That's crazy. Okay. Cool.
What's the
I want to try
units?
something.
It doesn't tell me
So it has to be units.
how fast, like units per second, if you want to say that.
I don't understand how you get
Just a second.
that part.
I don't know where you're pointing.
This. How do you get from here to here?
Okay. So 1 plus root t squared. What's root t squared? Just t. So it's 1 plus t times 2 root t. Oh my goodness. Awesome. Okay.
Don't read 2.
2 pages done. 1 to go, and it's just 1 problem. So
Smiles.
Oh wait, can you go back up?
I feel like this is actually not that hard.
that's why I only put 1 day for it.
No.
Huh?
God, what it feels like.
Yeah, I mean, what do you want me to do? Put the assignment in the middle of the page? Like, no, it looks not aesthetically pleasing. So put it on the bottom. That way, the new lesson starts on a new page. Because there is not enough space. There's not enough space for like to crush. Never mind. I did 2 pages. Okay. Whatever. Am I good to go down?
Oh.
Is this a long problem?
No, it's pretty much the same length as the last one.
It's really the same thing.
It's just okay. Ready? Okay. So, example 3. Find an equation for the line tangent to the graph of y equals tan inverse of x at x equals -1. Okay, so pause. We want an equation for the line. And ready? Everyone, look to your right. You're not looking to your right. Look to your right. What is here? Linear equations. When I'm asking for an equation of a line, look, wait,
on the quiz.
wait. If we find the derivative at a point, that gives me the slope. And if I give you a point, y1, x1, leave it in point slope form, and then you have an equation for a line. I don't know. I thought more people would get the bonus. I made this as a bonus on the chapter 2 test. No, the I don't know. Chapter 3 part 1. It's supposed to be like a simple problem, and I don't know. I was sad. Very few got it. Equation of a line. I'm not talking about the hard one.
Okay.
I'm talking about the one. You know what? After I'm done with this part of the lesson, I'm gonna go back and show you the bonus to one of your tests. Do you know the one I'm talking about? Where it was like, literally, here is f prime of 3, and I want the equation of a line at 3, 1. Like, come on. This is supposed to be a free point. Okay. I know. Okay, we're an equation of a line. Look, I wrote an equation of a line. Tangent to the graph, aka tangent means derivative, and we're going to be finding the slope. Okay, so what we need, the slope, just to be clear, the slope is going to be y prime of 1, and then our point is going to just be y of 1. I'm sorry, wait, -1? -1.
Right on time.
Wow.
This is so late, right?
Are you guys carpool?
Yeah, they do.
Ty decided to stay in the car.
Yeah, I think it's
You're just gonna skip my class?
100%.
I'm happy for the honesty. What?
No, she
I'm
drove
just
us.
joking. I drove her.
Oh.
Abby drove me today.
Oh, okay.
Yeah.
Do you guys know Ty's a baller?
Yeah.
For real.
So
You gotta come watch basketball. He's amazing.
Oh, I know what that means. Am I not a baller in some way?
Have you played this month that I watched?
Yes.
That I
You
watched?
should come to the week.
and,
You should come watch today after
Like
school.
this week, I've literally watched Ty play in 3 different games. Yeah.
This is our most loyal fan.
Yeah. Do you see? Loyal fan. Okay.
Mr. Bryant, do you know why I slept over at Abby's? Because she got it to me. And Gabe did too. Sorry.
Ah.
Did you do early decision? So you're 100% going? Oh my god. It was 100% mine.
Okay.
I have memory issues.
Okay, so we're still missing Talia and Maya, so I'm gonna keep screencasting.
Oh, they're so late.
Let's finish. I know Maya's coming from like way in there, right? From way Beverly. Okay, let's just finish this problem, then we can talk about fun stuff. Cool. So first, let's find the slope. First, let's find y prime, aka the equation. So we're finding the derivative, the slope for tan inverse of x. What is u here equal to? Okay, let me pause. Let me pause for a second, because we're gonna be a little late.
U prime is 1.
Yes. So y is tan inverse of x, y prime. So u is gonna be my x, and u prime is 1. So literally, when I plug into the algebraic expression that is the derivative of tan inverse, it's just gonna be 1 plus x squared times 1. Oh, literally, it is just gonna be 1 over x squared. 1 over 1 plus x squared. So that is the derivative of y. Now I have to find the slope at 1. I found the equation for the slope. Now I got to find what is the real number. So I plug in, right? So y prime of 1. So I have 1 over 1 plus 1 squared, aka 1 over 2. What?
But that's
Negative 1.
m. 1 over 1 plus x squared is m.
Yeah, but you don't want x in your slope.
1 over 1 plus x squared. So now, if x is equal to negative 1, let's find what the slope would be. So I plug in negative 1 for x.
So do you want
The slope is a half. Cool. So,
y?
what? What? So, we have the slope. Here's the slope. Let's go through. So I need an equation of a line. I found the slope. I need a point, and then I can write my line. So let's find my point. This is exactly what he was talking about. What is y of negative 1? Let's see. Y of negative 1 is going to be tan inverse of 1. So throw back to our unit circle. Right, so sine inverse, this is what I tried discussing before. We had a restriction, right? It only can be. So you said root 2 over 2, but that's what sine of 45, cosine 45, right? So when you have a 45-degree angle, tangent of a 45-degree angle would be root 2 over 2 over root 2 over 2, aka the same number, which is 1. All right, so you recognize it's a 45-degree angle. If you don't recognize it, we're going to go through right now. So sine inverse. So remember, sine is right? A little curvy curve. But the issue is, if I take the inverse, remember if I was trying, let me go up to show you. At the beginning of the lesson, I said, wait, look at this. If I have like sine and I'm trying to take the inverse, aka reflect it across y equals x. Ready? So I had you guys all turn right. Now I want you to take your head and move it at a 45-degree angle to your left. What I want you to do is have this be a horizontal line. Okay, this is the horizontal line. Move your head like this. Do you see how it is reflected across this line?
Yeah, I see that.
Yes. Okay, this is the inverse of sine. The issue is this is not a function. It doesn't pass the vertical line test. This is why we must restrict it.
Oh my god, so you have to do the
I only want
for when it's not a function.
I mean, that is why we're doing the chain rule. We don't have to do implicit because I gave you the equation for the derivative of the inverse. But what I want you to see from this is literally sine is only going to be defined between these two numbers. AKA, when I'm taking sine inverse, I only want the first and fourth quadrants. Yeah. Because I'm going from negative pi over 2 to pi over 2. All right, so when I take, sine inverse of, pick a number sine can equal.
7.
Sine can equal 7. That's not between negative 1 and 1.
0. 0.
1/5.
1.
0.
That sine could equal. Okay, 1. Where is sine equal to 1? Remember, I'm restricting it between negative pi over 2 and pi over 2.
Pi over,
Pi over 2.
yeah,
Pi over 2. Okay. Where is sine equal to 0?
0.
0. What about pi?
0.
Pi is not between my restriction.
Yeah.
Pi is not between my restrictions of negative pi over 2 and pi over 2.
What it is at pi is 0.
What?
0 at pi.
Yes, but if I was doing sine inverse of 0, I'm asking what angle is sine equal to 0? If you said pi, you'd be wrong because, yes, we did this. Chapter 1, section 6. Chapter 1, section 6. This is exactly what we did. Yes, I know, but I'm telling you exactly where to go for your notes. So sine inverse is between pi over 2 and negative pi over 2. We only use these two quadrants. Now, we're trying to find tan inverse of 1. There are two different places tangent is positive and two places where it's equal to 1. First quadrant, third quadrant. But we want the angle that's in the first quadrant because tangent inverse is only defined between the first and fourth quadrants.
So it's pi over 4.
So I only want to use these two quadrants. Remember, there's two places where tangent is equal to 1. And I want the one that's in the first quadrant. What is the angle where tangent is equal to 1? The first quadrant. 45 degrees. Pi over 4. So I know that this is equal to pi over 4. Meaning my point is going to be negative 1 comma pi over 4. I have a point. I have my slope. Let's find the equation line. Wait, what's the equation line? Oh yes, slope. Point slope form. We just have to plug it in. Equation y minus pi over 4 equals 1/2 times x plus 1. All I did was plug in my slope, my y1, my x1. And then that's it. That's the whole lesson done. Look at you go. I'm going to pause here because we still have like a minute or two.